Okay. So today we will continue with another method of the nonlinear equations.
Don't you start anywhere lah? Then I share the laptop with my friend.
Okay, so this is the third method. Okay, before this you learn about intermediate value theorems, and then the second one is bisection method, and this is the third method, which is Newton-Raphson method. Okay, so we can continue with this method. Okay, so basically this Newton-Raphson method, make it bigger. Newton-Raphson method. So this is another iteration method. Another iteration method to find the root, to approximate the root of nonlinear equation by repeating to find a tangent line. This one is by iteration method to approximate the root by repeating by a tangent line of fx equal to 0. So maybe I have to draw the graph so that you can understand. Okay, so let's say we have a graph like this. So even though it already got line, still bengkok. Okay, and then let's say we have a graph like this. Maybe let's say we have a graph like this. Okay, so we have a root right at here. Intercept at this exit. This is the root. Okay, so before this bisection, we have to do like by taking this one, right, interval, and then we divide by 2, and then we divide by 2 again, divide by 2 again. But this one, from this, let's here we got a x0. Okay, so at this point, this is the x0, fx0. Let's say this graph is fx, right? Can you mute your mic first? Okay, thank you. Okay, so kalau sini we have this point. So we start with drawing a tangent line from this point. This point, I draw a tangent line here. From this point, yang kena pada this point lah, titik tu. So I draw another slope lah. So this slope is f prime lah. Boleh sampai sini dulu. So at this new slope or this tangent line kita akan ada intercept kat sini, satu point. So let's say this one I put this x1. Okay. So kalau lah normally remember the the slope of the graph and dy dx. Then this is a dy dx. Remember or not last time? That means this part divided by this part. So kalau tengok at this point, this is x1 0. Correct or not? This point. Bukan, sorry. This point. Sorry, bukan that done. Not this one. Pada titik x1 tu. So here, yang ni sebenarnya kalau tengok yang ni titik dia adalah x0 0, betul. So kalau saya nak buat dy dx, that means dy dx adalah 0 in sini minus this one minus f x naught divide by, kalau x adalah, silap ini kenapa x naught, should be x1 sorry. So divide by x1 minus x naught. Ini divide dx. So dy dx we also can write in this form. Right. So sekarang saya nak tahu, I want to know the x1. So I just bring this one, the whole thing to here lah, right? So become now x1 minus x0 times f prime x0 equal to negative f x0. Okay. So now kembangkan, so become x1 f prime x0 minus x0 f prime x0 equal to negative f x0. Okay. So sekarang saya tadi kan saya cakap saya nak cari x1. So semua yang bukan x1 tu semua bring to the right. So now become x1 f prime x0 equal to x0 f prime x0 minus f x0. Now I want to get x1. So x0 f prime x0 minus f x0 divide by this one and f prime x0. So yang ini adalah this come how the formula of, kalau kita tengok yang ni kan, yang ni dengan ini kan boleh mansuhkan boleh mansuhkan kan. So now to simplify it become x1 macam ni. So means kalau this is the formula of we want to find the next x using Newton Raphson. So that's mean, and this I minus f xi f prime xi. So this is the formula. So this formula, you no need to remember. Is let's say come out in the test or final, this formula will be given. You only have to remember the step. Okay, so ulang balik tadi macam mana? Okay, sebelum ni, okay, apabila saya dah dapat kan this x1. When I get this x1. So from this x1, I will project like this. Project to this point, right? So and then I will draw another tangent line from this x1. Okay, now I got this x1 right? So I will draw another tangent line. Nak guna warna apa ni? And draw another tangent line. This one through this one. Melalui ni. This one. Melalui this. So this is f prime x1. So kalau nampak semakin menghampiri road tak? Is very fast. Daripada sini, road kan tadi sini. Daripada sini terus pergi ni dekat, semakin dekat dengan root. Kalau daripada graph you can see it's a very fast. Using these methods we can using these iteration methods we can approximate the road faster compared to the bisection. Kan bisection separuh. Kalau ini using the tangent line, kalau tengok macam ni, okay, only nampak first and then we do a tangent line terus. And then kalau lagi and draw again the tangent line. So macam ni lah. Apabila we get another road, katalah we get another road here and then we will draw another tangent line pula. Lagi. And then sampailah menghampiri approximate the roads. Boleh? Okay, class okay or not? Alzira, okay?
Okay, doctor, okay.
Okay, so we do the example. Okay, so this is a formula. Okay, so let's do the example. This one, 2.7. Example 2.7, if you look at your book, it will be page 18. Okay, so example 2.7, given the graph of fx is equal to x squared minus 3 as in figure 2.8, approximate square root of 3 by using Newton method. Okay, Newton method tu maksudnya Newton-Raphson method lah. That is a short form of Newton-Raphson method. Okay, so here dia akan ada dua. Kalau kiranya, if let's say we do the roots, we will have two, right? Square root ni akan ada dua roots lah. One is here, another one is here. One is positive, one is negative. So, ya, saya buka saya punya nota juga. Saya pun kena buat nota. Okay. So, kat sini dia ada tulis positif ke apa. Tapi buku ke apa dia tulis positif is to find the positive root of this one. Then choose dua. If let's say punca kuasa 3, kalau sini we will have like this one, right? And then this one, if let's say we want to find the x, should be, dikatakan tadi kan, okay, kalau tak, sorry, delete sekejap. Of this one. Step 1, go back to before this, you learned about step 1, we have to find the interval A and B. Okay, so now kalau ikutnya from the equation just now, this one. So daripada sini pun kita boleh nampak dia punya, we can look at here the, kalau using the calculator, if you calculate dapat apa? Saya boleh start kalau sini kan, you look this one is near to the 2, so you just can choose 2. Tapi cuma kan saya tak pasti kenapa dia pilih positif saja. Sepatutnya it can be both lah, either positive or negative. But mungkin dia nak positif saja kot. Normally they will ask you to find a most positive or most negative. Let's consider, we assume that this example asks we to find the most positive root. Okay or not? So, if let's say most positive root, kalau kita tak buat ni pun tak apa, sebab daripada ni we can see already. So near to 2. So we can take x0 as 2. So apa beza? What is the difference between bisection and bisection and Newton-Raphson? Bisection, before this we need to find A and B. Sorry, sepatutnya we find the value of x0. Sorry, this one, find x0. Find the x0. Tapi we have to make sure that this one is fulfill the intermediate value theorem. Kalau sini, let's say we want, okay, between 1 to 2 ke, 0 to 2 ke. So we have to make sure one is positive, one is negative. Tapi graph dah ada, kita tak perlu lah. Kita tengok saja. So this one we can just take x0 as 2. So for the Newton-Raphson, we no need to take A and B. We just need to take the x0. Start dengan apa? Maksudnya A lah. And tak kisah sama ada root tu di depan atau di belakang. You just choose the one that is nearer. Boleh faham apa saya cakap? Kalau sebelum ni kan, bisection awak kena ambil sini dengan sampai sini lah kan. So this one no need. Awak, kalau awak tengok, let's say, katalah satu kat sini kan, root tu jauh daripada satu. Kalau awak ambil, if you choose one, so you have to do more iteration. If you choose two, then your calculation will be shorter. Iteration will be lesser. Boleh? Oh. Okay, so now we choose the x0. And then, kalau lah, so that is quite near to the root. Okay, so we choose 2 because it's too near. Kenapa saya tulis sini Choose x0 equal to, okay. So that it is nearer to the root, to the positive root. I put here positive root. Okay, and then same with the previous, we have to draw the table. View table, and then find xi plus 1. So, kalau tadi formula xi plus 1, xi minus fxi bahagi dengan fx prime I. So, kalau dalam calculator, we just can key in like this. Just key in like become A minus B over C. Senang. Oi. Wait ah. This one become C. Okay, now I draw the table. So, now, draw this table. Lagi cepat guna tangan. Next. So, apa yang kita kena masuk? We have to put I, iteration, yang berapa, and then xi, and then fxi, and then f prime xi. These 3 items we need. This one, this one, this one. Okay. So, start with 0 iteration. We start with x0. X0 tadi kan, this one, x0, 2. Okay. So, using calculator, awak key in je that formula. This equation, sorry. Bukan formula, equation. X square minus 3. This one. So, okay. Alpha x square. Alpha x square minus 3. Minus 3. Then calculate 2. So you get 1. Okay. So f prime beza kan? Macam mana nak beza? Use calculator. Tak perlu kira lah. We no need to find. For example, just now your fx is x0 is this one, and then f prime x0 sama dengan kita ganti masuk 2 kuasa 2 minus 3, and then we get 4 minus 1, 4 minus 3 get 1. F prime x0 katalah. So become 2x and then sama dengan 2 time with the 2 become 4. Tak perlu. So using calculator saja. So here kalau nak guna calculator, awak nampak this one shift ni, nampak? Boleh. Shift ada pengambil integrate ni. So just key in alpha x square. Sorry. Jadi alpha x square minus 3. And then go down. This one x. Oops. X is 2. And then press sama dengan 4. Okay, boleh? Boleh
Lagi sekali.
Okay, so when I want to do the differentiate this equation, okay, saya tekan AC. So now go to shift, saya tekan shift. Lepas tu awak nampak yang ni pengamiran integrate ni. This one. This one, boleh? This one, tekan shift, tekan this one, press this one, and then alpha x square minus 3. Okay, so you go down, this one x, this one, bawah ni, x sama dengan, now because our x is 2, so 2, and then equal to, so become 4. Saya guna calculator satu lagi. Ada calculator. Sekejap. This one. Let's use this one. Zoom paling besar in this one. Kecil dah. So this one is shift this one. Nampak? This one. This integrate. So alpha x square minus 3. So go down, go now. Okay, press 2. Sama dengan. Okay, ada lagi siapa yang guna calculator FX 57MS? Ada? Any of you?
Ya, ada.
Ada doktor, ada.
Wait saya rasa saya kena tulis kat sini. So what you have to press is, okay, you have to press sama juga, you have to press shift kan? And then you go to this symbol, this one. Right. And then you our type je alpha, yang alpha ni, alpha tutup kurungan tu lah, alpha. Lepas tu alpha saya tulis x that's mean this symbol. Ini. Okay, alpha x and then square and x square and then minus and then 3. Okay. So, lepas tu awak kena tekan koma. Awak kena tekan koma. Awak nampak ada koma tepi M plus tu. Nampak koma?
Yes.
Ada dia.
Okay, koma.
Nampak,
And then you key in the value of your x. That means 2. And then awak nak tutup kurungan pun boleh. You don't want to cross the bracket pun okay. So and then you just press equal to. So you wait and then you come 4. Dapat tak?
Yes, thank you, doctor.
Huh?
Yes, can.
Sure can already, huh? So
Yes.
others, can you follow or not? Using
Ya, dia tengah try tak dapat.
5mx. This one. Calculator yang ni. Sekali saya ulang lagi. Awak pergi shift and then this integrate. So it will come, apabila you tekan ni, this will come this one, right?
Okey dah.
Dah kan? Lepas tu boleh? Dah.
Boleh.
And then you press alpha x square minus 3, tekan koma. And then 2. Sama dengan. Awak nak tutup boleh, tak nak tutup pun boleh. So okay? So we continue. So this means this is?
Doktor,
Yes?
nak tanya yang
Ya, Mukat.
kira untuk dapatkan yang X I tu yang macam doktor ajar tadi dah.
Sekarang kita guna tangent. Ni tangent tak ada atas tak. Sebelum ni kan ada AB and then we get a new C, right? This one we no need to get ABC, no need. Just X, lepas tu only this time we have to do the differentiate. We need to differentiate. Ni, this one. Yang sebelum ni tak ada kan, sebelum ni method bisection tak ada. Right. Bisection, we need, if let's say the bisection, we need A, we need B, and then we need C, right? And then we need FA, FB, FC, right? Yang C tu duduk tengah lah ni. Kan? Tapi yang ni tak. We only need X, Fx, F prime X. Okay? Boleh? Now, I want to find the next X. Now, I want to find the next X. Now, X seterusnya. So, apabila X seterusnya, I will use this formula. This one. This formula. This one. That means, if I key in calculator, I will key in like this. I will key in alpha A minus, and then alpha D divided by alpha C. So this will become A, this column become B, this column becomes C. Boleh? So A, and then you press calculate. A is 2. A is 2. That means X sama dengan, and B is 1. 1 equal to, and C is 4. 4 equal to. So I will get the next X is 1.75. Boleh? Okay or not? Azim, boleh Azim?
Boleh, Doktor.
Nuralia?
Boleh, Doktor.
Okay, so now we continue with just now the equation. We key in, kita belum key in lagi tadi. Alpha X square minus 3. So calculate, put in 1.75. So we'll get this one, 0.0625. Okay, lepas tu pergi yang beza tadi. This one. So now change this 2, change to 1.75. 1.75. So get 3.5. 3.5. Kita tak boleh stop lagi. Kita cuma boleh stop when this one, diff fx is less than epsilon. So now, the next iteration, we go up and find this equation. A minus B over C. So now, tekan calculate. A is 1.75. B is this one, 0.0625. C is this one, 3.5. So we'll get 1.7321. Okay? And then find the fx, calculate 1.7321. So get this one, 0.0002. So done, can stop already. Because already less than epsilon. So yang tu pun tak perlu kira. So kita akan tulis sin fx2 is equal to 0.0002 less than epsilon 0.005. So the positive root of x squared minus 3 equal to 0 is approximate 1.7321. Tapi soalannya yang ditanya punca kuasa approximate. So 7321. Boleh. So okay or not?
Doktor, epsilon constant.
Huh?
0.005 tu memang constant.
Tak, yang ni
Oh, dia berubah-ubah.
Tak lah. Tapi this one is acceptable maksudnya yang acceptable punya approximation lah kalau kurang macam ni. Maksudnya kalau let's say if we put this epsilon, katalah kita letak epsilon 0.1. So kita punya error tu besar compared to the exact solution. Sebenarnya. So kita nak maksudnya error yang macam ni dah cukup lah. Depend lah. Semakin kecil semakin bagus. For sure if let's say this one. Lagilah bagus. Tapi sampailah 5 decimal places tak perlulah. Tak apa. So kalau tengok juga, okay. So in these numerical methods, this numerical mathematics, basically we do in 3 decimal places or 4 decimal places. But in the real scenario, real case, in real engineering applications, depending. So maybe only 2 decimal places is enough. That means we just take a stop at this. Boleh. Ataupun mungkin can be 0.01 pun boleh. So ini bukannya mesti wajib, yang ini tak epsilon. So that's why epsilon ni bukannya nilai ni lah. Bukan nilai ni sahaja. So we can choose so which one you acceptable punya error yang kita boleh terima lah kiranya. So boleh. So we go to next example and then we go to exercise. Terus exercise. This one is much more simple, right?
Betul. Jadi saya yang 1 dengan 2 tu faham. Saya kurang faham lagi yang untuk yang kosong. Yang sebaris kosong. Untuk kira yang 1 dengan 2 punya table tu saya tahu. Tapi yang mula-mula sekali untuk yang 2, 1
yang ni tak faham. Okay. Saya ulang lagi. Okay. So, this method kalau bisection dengan Newton-Raphson method, kita buat iteration. Dia adalah iteration method. Maksudnya kita akan iterate, kita buat sampailah kita boleh dapat ni lah less than epsilon ni kan. So, tak kisah sama ada bisection or Newton-Raphson, we will start with the X naught kan. Yang ni kita start dengan X naught. Kalau tengok X naught tu kosong lah. Kita start dengan kosong. Iteration, kita tak buat lagi iteration. Kan, kita tak buat lagi. Sebab kenapa saya cakap macam tu, kita terus ambil daripada ni. Kalau remember just now, I draw the graph kan, saya lukis graph daripada sini kan. The first one ni kan, kita belum buat tangent line lagi. So, yang ni X naught. Yang kita tak buat apa iteration lagi. So, this is 0. Lepas tu apabila kan saya draw the tangent line, cari sini, X1. Kan? This is the first iteration lah kiranya. So X0 ni kan, kita nak pilih X0, kalau boleh kita pilih kalau ada graf macam ni, kita akan pilih X0 yang mana yang paling menghampiri root tu. Kalau daripada here, from here, look at from here, kan, is nearly 2. Dia dekat dengan 2 kan, is near to the 2. So that's why my X0, I choose 2. Okay, so in the table here, the first, this one is the 0 iteration. X0 tu apa? Kita start dengan X0 2 lah. So that's why I put 2. Boleh faham? This is kalau maksud sini, this is a X0, this is a X1, this is X2 and so on. And here, this is, kenapa terpadam? Itu maksudnya iteration yang keberapa. So here this is fx0. This one is fx1. Boleh faham? Fx2. Boleh faham tak? Ni tengok iteration berapa. Kalau ini 1, that means this is x1. So this one we start from the 0 iteration, start with x0, start with 2. So apabila fx ni maksudnya fx0. Apabila saya ganti formula ni kan. Ni kan, X dia saya ganti dengan X0. That means saya ganti dengan 2. Bila saya tekan calculate, saya letak 2, then I get the answer 1. So that's why I put here 1. Boleh?
Okay.
Boleh. So sama juga this one. This one is F prime X0. So maksudnya saya gantikan X0 tu 2. So I go to this Yang beza ni, okay. Saya letak X tu 2. So I get 4. Boleh? Boleh ya?
Okay.
Okay. So, we move to boleh ya example dah. Yes.
Sorry, nak tanya yang tulisan warna
Yes.
merah tu. Macam mana dia dapat yang 1.7321 tu?
Yang mana 1.77.
Yang tulisan merah bawah sikit.
This one. Okay.
Ya.
So this one I will choose this one. X. Maksudnya X tu adalah yang root ni. Root ni kan? Ni. Nanti saya zoom sekali. Ni. This is 1.7321 lah kiranya. This root. Boleh faham tak? So that is X. X.
Okay.
Root tu lah. Root tu adalah the value that intercept as X exists. Yang apa? Panggil apa? Kat Parsi panggil apa? Intercept panggil apa?
Persilangan.
Bersilang kat Parsi X tu. Nilai X yang bersilang di Parsi X. Yes. Okay.
Okay, clear. Thank you.
Okay. So, how about we continue with the exercise? We do exercise lah. I think this one much. Kalau if look at example 2.8, I guess is similar. I think similar. We just do. So we do example terus boleh. Exercise terus. Kita buat exercise yang dalam buku lah. Cuma, maybe I want you to try to draw the graph. Newton at 2.8. Ini ada. Ini kena buat lah. Nak buat example ke terus exercise? Exercise, kalau nak buat exercise, we can do exercise exercise 2E. Tak apa. We go very fast this one example. Saya pergi sekali lagi lah example. Okay, so go to this example 2.8. Okay, example 2.8. Find the most positive root of non-linear equation given in example 2.6. So I have to refer 2.6 by using Newton methods. Okay, example 2.6, given the graph of fx equal to 2x power 3 minus 5x squared minus 7x plus 6. Find the least positive root of fx by using, okay, ini tak boleh lah, using second method is not covered in your syllabus. Okay, so you don't need to learn that one. Okay, if you want to learn, you can go look at your book for your extra knowledge. Okay, take x1 minus x0 equal to 1 and iterate until the fx less than epsilon 0.0005. Okay, kalau daripada graph sini, dia cakap sini, least positive root. In here, we have 3 roots, right? 1, 2, 3, kan? And then, positive root, we have 2. 1 and 2. Yang paling kecil, this one lah, right? So, this one. So, we will take this one. It asks me to find this one, the root here. So, either you want to put x0 is 0 or 1. So, depend. So, if you will choose, sorry, list ke? Kenapa soalan betul tak? List. Why you choose 3
Doctor, because the question in example 2.8 need us for the most positive.
Most positive. Oh, okay, sorry. So, don't refer to this one because it's asked to refer 2.6. Okay. Sorry, So this one we no need to refer. This one no need to refer. Okay, sorry. The most positive root is this one. Thank you. Okay, so we choose this one. So kalau kat sini, kalau kita tengok is between 3 and 4, right? So, and it almost the middle, right? So either you can choose 3 or 4 also can, depend, okay? So if let's say it's nearer to 3, then we choose the x naught is 3. If nearer to 4, then we choose x naught is 4. Okay, so we continue the solution. So, first, step 1, okay, we find the x naught and where we need the most positive root. So from here is either 3 is between this value lah, 3 or 4. So we can choose x naught is equal to 3 lah. Okay. Then step 2, we build the table and find xi plus 1. Okay, so the buat iteration. This one is so this is I, xi, f xi, f prime xi. The equation just now is 2x power of 3 minus 5x squared minus 7x plus 6. Okay, so ini start daripada iteration 0. So just now we choose x naught is 3. That's why this one here we put 3. So boleh? So now saya akan key in kan this formula 2 alpha x power of 3 minus 5 alpha x square minus 7 minus 7 alpha x alpha x plus c, calculate. So the value of x is 3. So sama dengan negative 6. And then buat shift integrate. So this one bezel kan, masuk sekali lagi this formula 5 alpha x square minus 7 alpha x plus 6, and then go down, the value of x is 3 sama dengan, so this is 17. Right. And then next we find the value of x prime sama dengan x prime minus f prime x. So kita akan guna a minus b over c, and where this is a, this is b, this is c. So alpha a minus alpha b divided by alpha c. So calculate a is a 3, b is negative 6, c is 17. So we get 3.3529. Then AC tekan naik, find that equation, calculate when x is 3.3529. So we get 1.7062. Okay, and then continue lagi, gantikan this x with 3.3529. 26.9226. Okay, and then continue the iteration. Gunakan this formula. Using this formula, and put in A, B, C. Calculate. A is 3.3529, B 1.7062, and C 26.9226. Okay, then we get 3.2895. And then find the value of this fx when x is 3.2895. 0.0596. Tak boleh stop lagi. Belum kecil daripada epsilon. Okay, so have to find this one. Integrate 3.2895. 26.9. Betul ke saya? Salah sekejap. 3.2895. 26.9226. Is it the same? Am I wrong? 2895. Sekejap, tengok. Example 2.8. Wrong, Is it, sekejap. No. Apalah saya. 3 point here dia. Silap. Put here 2895. Okay. Then 25.0299. Okay, continue with the third iteration. Using the formula, this one, calculate. A is 3.2895, B is 0.0596, C is 25.0299. So get 3.2871. Calculate 3.2871. Okay. Negative 0.0004. Okay, dah boleh stop lah. Already. Sin f x 3 0.0004 less than epsilon. The most positive root of 2x more 3 minus 5x plus 1. .2871. There. Okay or not, class?
Okay.
Nur Husnina, okay? Boleh? Okay, so now we continue. Oh, 6.
Jatuh tu nak salin yang last.
Begat, tak ada buku Ini saya salin daripada buku saja. Apa?
Jawapan last doktor.
Jawapan last saya kenapa?
Saya nak tu.
This one?
Bukan, ni yang
Ayat.
ayat ni.
Okay, tak apa. Awak tak nak tulis macam ni, awak pun tulis this one, okay, less than epsilon, and then root ni pun boleh. Root equal to ini pun boleh dah.
Yang tu pun dah memadai ke?
Yes.
Oh, okay.
Okay, so we go for one more exercise maybe. Exercise 2. No. Okay dah. Okay, so we go to exercise 2. Exercise 2. Let's try exercise 2E. 1E. Saya tanya, kalau lah tak bagi graph tu, can you plot the graph? Okay, let's see. Try this one, the new one. exercise 2. And then one E. We say that given the graph of y equal to sine x and y equal to jangan in the figure. Kalau boleh, try plot dulu. Let's say soalan. Plot the graph. And find the root of sine x equal to using Newton Raphson method. Iterate until fxi less than epsilon. Katalah soalan macam ni. So let's say we have to plot the graph. To start dengan plot the graph. Kalau ada buku apa you can refer to page. This is a page 25 actually. Got graph already done over there. Let's try plot the graph. Kalau if using this calculator, dia akan tolong plotkan graph juga, tapi tak perlu. Saya pun tak pandai sebenarnya this calculator ni. A new one. Okay, so let's start with the step 1. We plot the graph. Dia kata ada 2 graph tu. Okay, so one is this y equal to sine x. So remember have to be in a radian mode. Ingat kena dalam radian mode kalau kita nak kira. So just key in sine alpha x. Right. Cuba kalau lah kita buat when x mungkin boleh buat dalam in small table kot. Small tak nampak pula. X and this is sine x. If let's say x start from -3, then calculate tekan -3. The value is -0.1411. Let's say calculate 0, 2. Kalau 0, 2, -0.909. -1. -0.8415. 0, 0. 1, 2, 3. Kalau sign dia terbalik dia. So it becomes 0.8415, 0.909, 0.141. Let's double check. 3. Oops. Okay, betul lah. So this is sine x. Kalau lah y equal to this one, epsilon x minus 3. So sama. Let's say we try this one also. Daripada -3. Oh. Lemak. X negative 3. We put alpha x minus 3. Calculate negative 3, negative 2.9502. Negative 2. Negative 2.8647. Negative 1. Oops. Negative 1. Negative 2.8321. 0. Negative 2. 1. Oops. Now 2. 4.389. 1. 3. 17.055. Katakanlah this one like this. Then you want to plot the graph. Let's plot this graph. Sorry. Biscuit. Wah, sampai 17. Negative 2. Negative 3. Negative 1, negative 2, negative 3. 1, 2, 3. Dah cukup lah. So at this point 0, 0. Kalau ini 0, 0. 1 nearly to 1. 1 nearly to 1. 2 nearly to 1. And then 3. 0 point. This one at this point. Then here sama. Nearly to 1. Nearly to 1. And this one. So macam ni lah kan. Sign. And this one. Let's try this graph. Epsilon x power x minus 3. So, kalau daripada, if 0, the value is 0 to this one. And then 1 is negative 0.28. 1 is negative 0.28. Macam ni. And then 2 is 4. Dah. Kemana dah sampai hujung sini dah. Yang tu tak perlu cakap lah. Satu lagi. 3. So, and here negative 1 is negative 2. Negative 2.8, nearly 3. Here. And then, separuh dulu. Negative 2.6, negative 2.6. And then negative 2.8. Negative 4.9. So the graph is something like this. So now we want to find, boleh graph? Kelas okay? Dah tidur semua? Boleh lah kalau
Okay.
Okay, langkah graph macam dulu belajar last time lah. Okay, now we want to find the intercept between these two graphs. Dia bukan melalui paksi dah. Sekarang bukan melalui paksi X tau. Yang bersilang antara these two graphs. So this is the road that we want to find. Kat mana? Di mana? Here. Right. So this. So between 1 to 2. So now, if let's say look at the graph, is near to 1, right? So I will choose 1. Okay. So kat sini, step 1 dah plot. Okay, step 2. Step 2. We have to kiranya
Doctor,
yes.
when exam the graph we need accurate number for each point, or can we just roughly draw the graph?
Can roughly can, but
Okay.
if let's say you want to, why I do this one, because I want to know where the intercept. I'm not sure, so I just do.
Okay. Thank you, Doctor.
If let's say, like normally, right, sine you know already, it will be as like this, right? The graph of the sine. But only if let's say I didn't calculate one by one, I don't know whether it will go like this or not. Sine can be like this also.
Yes.
Okay. This also sine.
Thank you, Doctor.
Okay, so now we find the x naught. So from the figure, I will take 1 because it's nearer to the root. Okay, so x1, 1, x naught is, I will take this one, which between interval 1 to 2, you can choose 2 as well. So after that, we have to draw the table, build the table, and find xi plus 1. Okay, so lukis table. Untuk cari, let's draw the table. Okay, so this is I, this is xi, this is f xi, this is f prime xi. So x, dia punya equation just now. So just now we have to find fx. Kan this a new combined cakap when this one sine x equal to epsilon x minus 3. That means okay, when we want to do the iteration in order to find the root, we have to do that to make sure that the fx become 0. So that means here we have to make these equations become 0, equal to 0. So from here it becomes sine x minus epsilon x plus 3 equal to 0. Okay or not? Boleh faham? So this is the formula that we have to key in. So here we have to key in sine x minus epsilon x plus 3 equal to 0. Dengan cari x prime x, yang ni kan sama dengan a minus b over c. Remember or not? So this is a, this is a b, this is a c. So we start with the 0 iterations. X naught just now we choose 1. So now key in this formula. Remember, because this is sine, have to be in radian mode. So sine alpha x, sine alpha x minus, shift this one, alpha x, okay, turun bawah, plus 3. So here calculate the value of x is 1. So get 1.1232. Okay, boleh, class boleh. And now I want to do this f prime. That means we have to do the, we have to differentiate. So shift this. So key in the equation again, sine alpha x kurungan minus shift alpha x, lepas tu turun plus 3. Lepas tu go to this one, x is 1 sama dengan, so this is negative 2.1780. Dah wrong. So and then continue, okay, using the formula just now, alpha a minus alpha B divided by alpha C. So calculate A is 1, B is 1.1232, C is negative 2.178. So I get the next X is 1.5157. Oh yeah, sama, betul tak? Correct or not? Aina, do you get same with me? And then,
Yes.
okay, so, and then we solve this one. Calculate 1.5157. Negative 0.5541. Okay, and then, yang ni pula. 1.5157 negative 4.4975. Okay, next, calculate A is 1.5157, 1.5157 negative 0.5541 negative 4.4975. So the answer is 1.3925. So calculate 1.3925 negative 0.0408. Tak boleh stop lagi. So this one 1.3925 negative 3.8475. And then next, find the next X, X3, that means A, calculate A is 1.3925, B is negative 0.0408, C is negative 3.8475. Okay, 1.3819. Calculate 1.3819. Okay, 0.0002. Okay, so now we can stop. See, fx3 is equal to 0.0003 less than epsilon. So the root of sine x equal to ex plus 3 is approximate 1.3819. Okay or not, class?
Doktor, boleh tolong ni tak yang untuk apa kalkulator yang FX 570 MS1? Tu nak buat yang F prime tu.
F prime.
Boleh tunjukkan tak? Sebab saya try tadi tapi dapat syntax error. Takut saya salah tekan.
Okay. Kalau nak masukkan formula, okay. So, pergi shift kan? Shift. Lepas tu pergi this logo kan? Okay, shift ni. Lepas tu masukkan sign kan? Sign. Lepas tu awak buka kurungan dulu. Okay. Sebab sin X tu kan awak biar dalam kurungan. Sebab dia tak keluar kurungan kan?
Okay.
Okay, lepas tu pergi alpha X. Pergi alpha. Lepas tu pergi X lah kiranya. Pergi X. Okay, lepas tu tutup kurungan. Okay, lepas tu pergi minus. And then pergi shift lon. Awak pergi shift, lepas tu awak tekan ni lon. Shift lon, okay. Lepas tu kalau nak awak takut salah shift lon, lepas tu awak buka lagi kurungan untuk dia punya power. Lepas tu tekan alpha x lagi. Alpha x. Alpha x. Okay, lepas tu awak tutup kurungan. Okay. Lepas tu awak plus 3. Lepas tu awak pergi comma. So we start with this one lah. Okay. X equal to 1, comma 1. So sama dengan. Okay, dah boleh. Negative 2.177.
Yang lepas 3 tu ada tutup kurungan ke tak ya?
Lepas 3 awak kena koma.
Koma 1 kan? Koma 1.
Lepas tu 1 tak tutup pun tak apa. Sama dengan terus pun tak apa.
Tutup pun tak apa kan? Lepas tu tekan calculate
Tekan sama dengan.
Oh, sama dengan.
Others can or not using this FX?
Okay, dapat.
Boleh.
Boleh. Tadi tak buat
mungkin
yang ni.
Kurungan.
Kurungan saya ada tertinggal. Saya tak buat kurungan, saya ingat boleh buat. Tu yang syntax error tu. Yang ni boleh, dah dapat dah.
Okay. So remember to put this one lah. kurungan. Sebab kalau yang calculator yang baru ni dia automatic keluar kurungan bagi awak. Tapi kalau calculator yang lama tu tak ada. So dia itu sikit lah. But any of you have problems with your calculator or not? Casio FX 570 MS. Ada masalah lah. So far semua okay. Engkai Chi?
Yes, doctor.
Okay or not?
I'm very okay.
You're using which calculator?
Both calculator also got used.
Both.
Yes.
Rich. Okay, so wait, I stop recording. So I think